All our bridges and buildings and industrial structures are all made use of steel. Now steel is not at all used. Steel is not a competing material, the concrete, for many reasons. I'll not go into that. So, because the making green concrete, a concrete making make use of ordinary Portland cement will be a challenge for which already we have taken steps. Use of fly ash at one time, say about 25, 30 years back, or in America they are using the first time they used in the 1848. Sorry, 1948. 1948 in America they used the fly ash for the first time in Hungary was done. So as far as back, and we are late in making use of the fly ash and other pozzolanic material or supplementary cementitious material is rather late, and you will find that, and more industrial waste are coming, and we are finding the utility of that. Say, for example, just to give you one example, that so many tires, if you can imagine, if you can just calculate the number of big tires, lorry tires, car tires, or this tire, that tire, etc. In the whole world, how they are accumulating, and the difficulty in disposal is tremendous. Whereas in Japan, they are not throwing it away into the sea. It will again pollute back like that. They will not be buried. It will pollute the underground water. There is no way of it. They only where they can make use of is the concrete making practice. They cut into small pieces, make aggregate. These are rock aggregate, this is a rubber aggregate. It may not be as good as the made from the stone, but it is good enough for many purposes. All the concrete is not high-strength concrete, and you can use the aggregate like that, or even for that matter, glass. The glass can be used as a powder, and it can be used as a supplementary cementitious material, a pozzolanic material. So like this, as the necessity comes, as I told you, fly ash can be used. In India, you are using so much of fly ash. About 150 million tons of fly ash they are producing in India. With about 150 thermal power station. 150 million tons. How much of cement you are producing? 300 million tons. 50% of the cement you are producing fly ash. But you must know how to make use of this fly ash judiciously, in an economical manner, and a useful manner, in a harmless manner, to make it as a harmless material. Otherwise, earlier, the fly ash was dumped into low-lying area, dumped into railway embankment, and things like that. And there is not a correct method of disposing of. The rain comes and a lot of elements, dangerous element, poisonous element will permeate down into the underground water and it will spoil. Or it will fly over and come back and settle on the vegetation. Like so many things like that. So you are finding now this fly has become a precious material. At one time it was not costing anything. Now it is costing nearly as much as cement, not as much cement, but nearly like that. A time will come, it will become a very precious material. So that's what. So the necessity will make your mind tickle, and you think over, and always you meet the challenge. The human being so far, they met the challenge, and so-called progress has been made, but the real progress or not, we don't know. That's why. So if it's a real progress, this corona would have been trouble. So, okay.
Okay, sir. So we have discussed about the concrete and its strength. Now coming to the composite action of concrete with reinforcement, the next question is, why are stainless steel bars not used for reinforcement in concrete? The question is asked by Yagya Dev Tripathi from Northeastern Railway.
Stainless steel bar is being used, not as much as in a common manner, because it is much more costly than ordinary mild steel. It has been used. But why not in a universal manner? Why it has not become a popular material replacing steel? There are many reasons. But one of the technical reasons is actually stainless steel is smooth. is not rough. And as a rough in a sense, a comparative thing, is not as rough as that of the mild steel. There's a one thought is there. Rusted mild steel is better than slightly rusted mild steel is better than newly brought mild steel from the factory. It's like that. One line of thinking is there. So a certain amount of roughness in the steel is required to have a proper bond. The whole reinforced concrete theory is based on the bond, a good bond is between cement paste, not concrete, cement paste and steel. The whole fundamental theory is there. Now, if it is a stainless steel being so smooth, the bond is not there, and thereby the bond strength from the for bond strength is not there. I'll give the example, another example for that one. I roughed a bigger aggregate, freshly crushed. At one time it was a broken, so hand broken. Afterwards, the crushed aggregate. Until recently, it's about 20 years back, it's a crushed aggregate, and it is rough. That is found to be better with respect to bond strength. Say, for example, road aggregate, a crushed aggregate is better. Then you compare to the gravel aggregate, the river-worn gravel aggregate from the river bed. There are many places they don't have the crushed stone, they have only river gravel. Maybe if you go to the Calcutta and that side, Lucknow, the Calcutta that side, the stone is not there. So the rough, what I'm trying to say is surface texture, rough surface texture, when you consider the bond only, bond between the paste and the aggregate paste bond, it will have a higher bond than that of a smooth textured river gravel like that, from bond strength point of view. So stainless steel being so smooth from bond strength point of view, it has got a lot more shortcomings than the mild steel. Though it is stronger and it is not corrodable, corrosion will not take it that easily. That way, from the durability point of view, there, wherever the durability is of utmost important, wherever the durability of a structure, the utmost importance, then in such situation, stainless steel reinforcement is used. Similarly, even for the fusion bonded epoxy coating in Mumbai, all the government works, they use all, you can say 90%. They use not the mild steel as a reinforcement, fusion bonded polymer coating. The reinforcement is actually coated with the fusion bonded epoxy. Sorry, I am not yet. Fusion bonded epoxy coating is done. Even in that case, one of the shortcomings is that fusion bonded epoxy coating being smoother and its bond strength will be less. So you got to, in the calculation and all that, you got to appropriate take the bond strength between steel and concrete. Roughly you say concrete, but it's actually paste. So stainless steel can be used, but only in the special requirement. There is a special requirement. Yes.
Okay. Now the next question is asked by TV Sivashankar from TCE, that what changes do you suggest in our curriculum for engineering graduates which will help them align with developments in concrete technology?
Yeah. No, though it is a wider question, it's a too big a question, not for any one individual to reply or suggest the method. I can only say one thing, being a concrete technologist and having seen the industry from very closely for 30 years. 35 years I taught in the college, and the 30 years I worked as a consultant. More than 65 years having been in the education field and in the industrial field, I can tell you today, for a civil engineer, the knowledge of concrete technology is of utmost importance. Utmost important. Say, for example, concrete technology become useful for after undergraduate passing out and become a B, get a degree. If it is 100%, 100 students are coming out, I'm not giving the correct, accurate figure. I think about 80% of the people, out of 100, 80% of the people will come for the construction field. Maybe road or naval works or airfield work or civil works, industrial work, and whatever that happens. Metro works, monorail work, whatever, the railway, anything there. It's all civil engineering construction. Even when you come to nuclear work, or satellite communications, or Sputnik, or anything that you think about. For example, now nuclear power is becoming very important. Nuclear energy. Even in nuclear energy, a civil engineer, the concrete technology, will be of a utmost requirement, importance for him. Because a lot of construction is involved, the thermal power station is involved, the pressure vessel is involved, and out of concrete, and thermal, the biological shielding is required, all of concrete, heavyweight concrete, like that. I am talking for anything. You may be even talking about any branches of engineering. Civil engineering is the mother of all branches of engineering. I need not articulate more on that one. So 80% of the civil engineer will know, or I put it this way, will spend their lifetime starting from day one till they retire, beyond they retire, till they're able to do some work, maybe at the age of 80. I've been working till the age of 90. There are like me, there are many people, knowledgeable people. They have got useful knowledge based on their work of 50, 60 years of work behind them. So the concrete technology knowledge is the most important thing. That day I told, when I came in 1954, July 19th, when I went to the site, I was making concrete. I was a silent observer. The concrete was made by Mestri. I was not in a position to put this way, that way. No, I was not in a position to guide because I had not learned anything. Of course, today's engineering is slightly better. Even today, the concrete technology is not main as one of the main subjects, like building construction or soil mechanics or whatever is there. It is not one of the main subjects. It is just an elective subject. That also has become recently. Otherwise, it is just taught as a building material, like a building material. So it is not taught as a full subject. So I'll cut short my further discussion. For in the curriculum, the concrete technology should be made as an important core subject. Much better, much stronger than it. Of course, structure and things like that is required. Even one goes as a structural designer, but he needs the concrete technology knowledge. There is a melody now. In India, we find that I find the structural designer, he doesn't know concrete technology. He said, this one picture he gives like that. He will not, he's a structural designer. He's good. He may be very good. He may be as good as anybody else in the world. But he's not a concrete technologist. He doesn't know how to make good concrete. His concrete structure, without good concrete, will not survive, will not be useful. Even he himself will suffer by the failure. For example, 2007, I became a consultant to India Bull, and we are making 60-story building. with a 3.5 feet basement, 3.5 meter, sorry, 3.5 meter basement. And 3.5 meter basement, mind that, these days you go to the column and say, for about 50 meter by 50 meter is the base area, and obviously 3.5 meter is the basement thickness. And the temperature control and other things, I will not go into that one. Maybe I may be touching upon that later sometime. So 3.5 meter of concrete, if you put that one, the temperature etc. is becoming so much. The temperature will become, the maximum core temperature will become about 70-75 degrees centigrade. The concrete temperature in the core become 75 degrees centigrade because of the heat of hydration. So that will be, and surface will be in the ambient temperature. Core is 75 degrees. The difference in temperature make the concrete crack. Tensile cracks will come. This is one of the most important things we are neglecting now. We are neglecting just because the structural designer do not appreciate the temperature development of the concrete in a mass concrete and the harm that it will do in the for the integrity of the structure, concrete structure and texture. So I am mainly wanting to tell you why our structural designer, whosoever it is, he did not allow us to put 60% of GGBS. We have put as 20% of 60% of GGBS, about 10% of fly ash just for the correct what you call the rheology of concrete. 10% of fly ash, not as a main material, and 60% of GGBS and 30% of cement, so that the temperature rise will be so much reduced because the temperature comes from really the cement. It is the cement which gives the heat of hydration, tremendous heat of hydration. Whereas the amount of heat of hydration given by the GGBS or fly ash is nominal. So the temperature, the core temperature which would have gone to 75 degrees, by putting 60% of the GGBS, the maximum temperature, core temperature may become perhaps 50 degrees or something like that. We can take care of that one. But our structural designer did not allow, because he doesn't know in what way the GGBS will reduce the peak temperature in a mass concrete. He will not allow. He says by, we have given a mixed design, the strength will come. Strength is not the criterion, calculation is not the criterion. But he doesn't know how the GGBS will reduce the heat of hydration temperature because he doesn't know concrete technology. And there's a big argument and fight between us, technical team, and structural design. Finally, just to keep up his pace, he said, all right, reduce by 5%, 55%. This is the thing that happened. What I want to say is the structural designer are not concrete technologists. He is building a structure. As per the design is concerned, is all right, is the best. And many other things, like this 101 example I can give you. But I am also saying there is another structure called Nathani Heights, 75-story building. The structural designers from America. They are much better. They understand the creep of the concrete, the temperature of the concrete, the early temperature cracks, etc. Early temperature crack, etc. of concrete. That's what he understands. He has been trained, and we didn't have much of problem. So there is a thing. So what is that? What is the thing that I'm talking about? That is the concrete technology should be made into a core subject. One of the important subject in that curricula is level. That is what I think. I got a lot more.
Sir, you're talking since last 2 hours. I think we should take a small break of 5 minutes now.
Yeah, may not be 5 minutes, but
5 minutes. Yeah, we will take a break of 5 minutes, and then we will start.
I'll take some.
Okay. Yeah.
And we have to complete also.
No problem. You tell all the listeners and listening to me, they also take a little bit of water or a cup of tea or whatever.
Yes, sir. Yes, sir. Okay, all participants are also requested to take a 5-minute break.
Okay. If they want, no break for me because I need more time. I think I'm talking too much. As I told you in the beginning itself, all professors have got a wrong habit of talking more. So, talking more. Always for me, if I'm speaking for 1 hour class, always it is not sufficient for me. I need 1.5 hours or so. Because you touch one subject, other subject, other subject, other subject like that, and you go more peripherally to a main point, which is important. It is important. That's why I must now, because just the time I must cut short my talking.
Okay.
As a matter of fact, since others can't talk, otherwise they have to talk to me in between. So I don't talk too much. In the sense that not that way. So they may have cut short my time because I got to answer many more questions.
Yeah. Sunil sir, do you want to discuss something with sir?
Yes. Okay. I think we'll go a little bit faster. How many questions have come?
Sir, total 32 questions are there, and we have completed yet 7 questions.
7 questions. What changes you suggest? Changes in the curriculum. It's a very general question. Dr. Shilpa Shri, 5 minutes over.
Sound is there.
Pardon?
Audible?
It's audible, but I think she is gone to take a cup of tea or something. She is not there. Now it is 5 minutes break, she said.
Oh.
She'll come back.
You need water?
No, she what is I think. ಜೊತೆ ಈಗ ನೀರು ಹಾಕಿಲ್ಲ ಸ್ವಲ್ಪ. ತುಂಬ ನೀರು ಕುದಿಲ್ಲ ಇಲ್ಲ ತಡ.
Hello?
Yes. I think.
Shall we start?
I am not seeing you. Shall we start?
Shall we start, sir, again?
Yes, yes. All right.
Yes, sir.
What is the next question?
Okay. The next question is asked by Jayesh Bhagat from Rice.
Question number.
Number 8. The question is, what changes one should do while designing concrete mix for pavement from the design of mix for structural concrete?
Yeah. Oh, I think it's slightly vague question. Perhaps the person who has put the question, he wanted to know in what way the pavement quality concrete, in what way, under what principle the pavement quality concrete should be designed, mixed design should be done in comparison to or in contrast to the other structural design, a building component or something. Yes. So the underlining point that you want to make is actually more normally concrete mixed design is done for compressed system. Most of the structure, the concrete is meant for taking the compression, not for taking the tension. Or whenever the tension is coming, then the reinforcement is there. It will be separately designed separately. The amount of reinforcement is there to take the tension, and concrete will take the compression. And the concrete in the tensile zone is actually neglected. It is not taken into consideration. But when you talk of the PQC, pavement quality concrete, these days for all our national highways, the concrete rigid pavement is done, then the mixed design should be done a slightly different way. It's really not necessary, but people who are involved in that one, the Cement Research Institute, CRRI, or other people or mixed design and dealing with the pavement quality concrete, they say the PQC should be designed on the basis of flexural strength, not compressive strength. What you do, the procedure is there. Even the flexural strength is taken into consideration, then it will be converted to compressive strength, equivalent compressive strength, and then the mixed design is done. So the design principle is based on the flexural strength. The design procedure is actually from the flexural strength, you go back to compressive strength and then do the mixed design for the compressive strength. Instead of taking a compressive strength is taken to consideration for the compressive strength. Flexural strength is taken and converted to compressive strength, equivalent to compressive strength, and then the mixed design is done. Why it is done like that is actually the failure of pavement. Often it is considered due to beam action, something like that. Concrete will work as a beam because maybe mud pumping, the concrete is not subject to purely compression member. It is converted to a beam action. The mud pumping, it will be supported between one side and other side, and in between the mud is removed, mud pumping, etc. And the concrete, the pavement will act like a beam. So that's how is the flexural strength is considered for the strength of the PQ like that. Maybe because of that. So it is actually mixed design is not completely different, but it is the flexural strength of the pavement is taken, concrete in the flexural strength of the strength is taken, and it is converted to equivalent compressive strength, and the mixed design is done. There is nothing much difference in that one, actually. I hope the person who was questioned is put the question is satisfied. Yes. Next.
Okay. Now the next question is a little bit opposite of the question which we have dealt with right now. Why is pervious concrete not being widely used?
How can we? No, it is at what?
Question number 12 is there.
Question number 9.
Okay. The question is, how can we avoid seepages from cement concrete? The question is asked by Ajay Manjrekar.
I think good thing that you have left this question, because how can you avoid seepages from seepages? Not a correct word anyway. From cement concrete. In other words, how can we reduce the permeability of cement concrete? That is the right question. Seepage is a particular situation. Seepage, leakage, etc., etc. But it's all permeability of the concrete. So it's again a very, very general question. All of the precautions taken in everything put together is for making good concrete, is for making impermeable concrete. So I got to list out all that precautions taken, including batching, mixing, transporting, placing, compacting, curing, everything, or many other things required will be for making a good concrete, an impermeable concrete.